Welcome to Mystic Sci-Fi YouTube channel. Subscribe to get more such videos. Hey friends, today I'll be giving you a basic overview to linear motion. Ready? Let's get started. Linear motion, also known as rectilinear motion, is a fundamental concept in physics. Imagine you are in a car moving at a constant speed on a straight road. That's linear motion in its simplest form. Linear motion refers to movement in a straight line. To understand it better, let us discuss about position, velocity, and acceleration. First, position. This is where the object is located at any given time. Think of it as a point in a number line. Next up, velocity. The velocity of the body is its rate of change of position with respect to its surrounding in a particular direction. It is a vector quantity. It is measured by the distance covered in a particular direction per unit time. Now, what is this vector quantity? So, there are two important terms. One is scalar quantity, another one is a vector quantity. A scalar quantity is the one that has magnitude only. Examples: mass, volume, time, density, etc. Vector quantity is the one that has magnitude as well as direction. Example: force, velocity, acceleration, movement, etc. Velocity is equal to distance covered in a particular direction upon time taken. V is equal to s by t. Its unit is same as that of speed, that is meter per second or kilometer per hour. There are three kinds of velocity basically known, which are uniform velocity. If a body travels equal distance in equal interval of time in a same direction, it is said to be moving with a uniform or constant velocity. Variable velocity. If a body travels unequal distance in equal interval of time in the same direction, then it is said to be moving with the variable velocity. Or if it changes either its speed or its direction or both, shall be again said to be moving with a variable velocity. Average velocity. The average or mean velocity of the body is the velocity with which the distance traveled by the body in the same interval of time is the same as that with the variable velocity. If u is equal to initial velocity of the body, v is equal to the final velocity of the body, t is equal to time taken, s is equal to distance covered by the body, then average velocity is equal to u plus v by 2. S is equal to u plus v by 2 into t. Acceleration. The rate of change of velocity of the body is called its acceleration. When the velocity is increasing, the acceleration is reckoned as positive. When decreasing, as negative. It is represented by A or F. If u is equal to initial velocity of the body in meter per second, v is equal to final velocity of the body in meter per second, t is equal to time taken in seconds during which the change has occurred, the acceleration A is equal to v minus u by t meter per second upon second, or A is equal to v minus u by t meter per second square. From the above, it's obvious, if velocity of the body remains constant, its acceleration will be zero. If you are pressing the gas pedal and your car speeds up, that's acceleration. The accelerations which opposes the direction of travel are called decelerations. When you hit the brakes and slow down, the vehicle experiences deceleration. So if your car on a cruise control on a flat road and there is no wind resistance, you stay at a constant speed. The motion graphs helps us visualize motion. We encounter three main types of motion graphs: position versus time, velocity versus time, and acceleration versus time. Position versus time graph. This graph represents an object distance from an observer over time. It shows how far the object is related to the observer. The velocity versus time graph. This graph gives us the idea about velocity versus time, indicating how quickly it is moving relative to the observer. Acceleration versus time graph. This graph represents acceleration versus time, showing us how quickly it is accelerating or decelerating related to the observer. Linear motion is the foundational to understanding more complex physics concepts, and it's all around us in cars, boats, and even space travel. Got it? Great. Thanks for watching. Don't forget to like, subscribe, and hit the bell for more physics fun. Catch you next time.